as in previous video, I discussed the basic principle of the gas power plant. Now, in this video, we will solve the problem of the gas power plant. Now, as you can see, there is the layout and the TS diagram for the problem. Now, as you can see in TS diagram, there are two pressure line of 1000 kilopascal and 100 kilopascal, and there are also two temperatures, 300 Kelvin and 1400 Kelvin. Now this is the data of the problem. The things which you want to find are the enthalpies of all four stages and the efficiency of the total power plant. Now first we have to find the enthalpy at the stage 1. So as it is air, we will go to the A22 table, which is at the back of the book, which I have mentioned in the description. After opening the table, we go to the temperature of 300 kelvins. As you can see, at this temperature, the enthalpy is 300.19 kilojoules per kilogram, and the relative pressure is of 1.3860. Now we will use all of these values to find the second enthalpy. Now to find the second enthalpy of the problem, first we need to find the relative pressure of the second stage. Now to find that, we have to use this formula. As you can see, the relative pressure of stage 2 divided by the relative pressure of stage 1 is equals to the absolute pressure of stage 2 divided by absolute pressure of stage 1. Now the reason that we are using the relative pressure is that because it is air, so it pressure relates to the pressure of air in the sea level, so we cannot use the absolute pressure. We will use the relative pressure values. Now putting the values in this. Now as you can see, PR2 divided by 1.836 is equals to 1000 by 100. Now we will multiply both sides with 1.386. This come out as PR2 is equals to 1000 by 100 into 1.86. Now we will calculate it, and we get the PR2 as 13.86. Now again we go into the A22 table, and we will see this value if it matches in the table. Now as you can see, at the temperature of 570 kelvins, we have the PR value as 13.50, which is the closest to our answer, so we will use this value. Now enthalpy is also given, which is 575.59. Now we will calculate the enthalpy of stage 3. It will be calculated as same as we calculated the enthalpy of stage 1. Now here the temperature is 1400 Kelvin. So again we will go into the A22 table. Now as you can see in this table, the relative pressure is 450.5, and its enthalpy is 1515.42 kilojoules per kilogram. So this is the enthalpy of stage 3. Now we will calculate the enthalpy of stage 4. It will be same as we calculated the enthalpy of stage 2. Now again we will use this, that is PR4 by PR3 is equals to P4 by P3. P4 is 100 and P3 is 1000, and as we calculated, the PR3 is 13.86. Now we put the values, and here it is. Now we multiply both sides with 13.86 and we calculate it. Now PR4 come as 45.05. Now again we will go into the A22 table. As you can see at 45.55, it is the closest to our calculated value. Its temperature is 790 kelvins and its enthalpy is 810.99 kilojoules per kilogram. So we have calculated all the enthalpies of all four stages. Now we will calculate the efficiency. Now we will use the formula of efficiency, which is as you can see, work done of turbine minus work done of compressor divided by the total heat supply into 100, which will give the value of efficiency in percentage. Now the work done of compressor is enthalpy of stage 2 minus enthalpy of stage 1. Now when we calculated, the work done of compressor comes out at 279.7 kilojoules per kilogram. Now we'll calculate the enthalpy of work done of turbine, which is enthalpy of stage 3 minus enthalpy of stage 4. This come out as 706.9 kilojoules per kilogram. In the end, we will finally calculate the U in the heat, which is from combustion. It is of stage 3. Enthalpy of stage 3 minus enthalpy of stage 2. This come out as 935.5 kilojoules per kilogram. Now we will put all of these values in the efficiency formula. It will be 706.9 minus 279.7 divided by 935.5. This will come out as 0.457, and if we convert it into percentage, it will be 45.7%. So this is the efficiency of our power plant as we use the constraints given. So this was the simple problem of gas power plant. Now in the next video I will discuss the improvement of the gas power plant. I hope you understand this problem. So like, share and subscribe my channel. That's it for today. Thank you for watching my video. Khuda Hafiz.